Hi, it's the Reckless Retiree here with another wild and crazy experiment. In this experiment, I'm going to be using HHO, hydrogen and oxygen mixed together, separated by electrolysis, by a torch. I have a HHO torch, which I've shown before. I showed filling up the plastic 2-liter bottles, which I had modified with that gas. And so what I had in mind was trying to use it as a quote-unquote space heater, or a like a fireplace, like gas logs, but different. Much different. It would have to be much different if you're talking about the Reckless Retiree, right? Okay. So I will show you my setup. First of all, I have this photograph of the thermostat upstairs, where we have the thermostat set at 66 degrees, and it is 66 at the thermostat. Now I'm in the basement, the finished basement, and I have this photograph, which shows the temperature in the basement at 65 degrees, which is really curious because I feel very warm today. I have my Reckless Retiree lab coat on and a hat because I don't want you to be blinded by my chrome dome, but I also have my digital laser infrared thermometer, which we can check the various temperatures of the room. And so over here I have this fireplace that we got that is to be used with alcohol, cans of alcohol. But I've found that I don't like heating with alcohol because it leaves a funny smell. And you wonder, I feel funny after being in a room heating with those cans of alcohol. So, let's see. I don't remember if I have this so you can see the, let me tip this a bit. All right, so you can see as I point with my laser pointer here, right here is the HHO torch. And as you can see, the line from the torch, from the gas maker, goes over here to the fireplace where the torch is set up. Okay, so over here, inside the fireplace, I have a little chemistry stand right here holding the torch, and it is directed at a tungsten cube, which is sitting on a crucible, which is sitting on a fire brick. So the idea here is that I would light the HHO torch, which burns at a very hot temperature, and it's directed at a tungsten cube, which melts at an even higher temperature. So it should not, well, I know it doesn't melt. It doesn't melt the cube. But the idea is the cube would be a heat sink and then radiate the heat into the firebox, which would then also be radiated and through convection bring the temperature into the room. So if I take this thermometer, and I think it'll work from this far away, and I direct it at the back of the fireplace, we see that it's reading 64 degrees. I also will direct it at the tungsten cube, also reading 64 degrees. And the torch itself, which is 63, it looks like. Okay, so now I'm going to open the valve on the torch and light the gas and direct the flame at the tungsten cube. And we will periodically check the temperatures of the cube, of the torch, of the back of the fireplace, and also the thermometer that was on the table behind all of this. And we'll see if this makes any impact at all on the temperature of the room. Now, I chose this room because it's small. I closed off the 2 doors to the other parts of the basement, and so in an emergency situation, we have come down to this room in the bitter cold of the winter when the power goes out, usually due to an ice storm, taking down the power lines. And we have used the alcohol to try to heat this room. And it makes an impact. But the problem is, like I said, you're breathing those alcohol fumes. Now, I'm not totally without alcohol fumes at this point, because the torch, as you can see right here, has a bubbler. So in other words, it has a cell inside, that electrolysis cell, that separates the gas out of the water, and then it's fed into that bubbler, and that is a combination of a cleaner. In other words, it cleans any whatever chemicals, water out of the gas, and then the gas goes down the tube to the torch. It also, I think, can act as a back flash arrestor, because if you'll notice right there at the top of the bubbler, there is a little pressure release valve. And I can pull up on it right now, and you could hear the gas escape. All right, so now when I did that, it activated the mechanism, which is now making more hydrogen to make up for the gas that escaped, the HHO, the gas that escaped. And it looks like it's reading around 13 amps. It uses 13 amps to break down the gas. So anyway, first of all, I want to see if the torch directed on the tungsten cube will have an impact on the temperature of the room. Secondly, I can see if, if you can smell the alcohol fumes just like you do with the alcohol can. I'm thinking if there is some smell of the alcohol, it'll be much less than the burning of alcohol than bubbling through it. But if that's a problem, then I can come back and remove that alcohol and replace it with distilled water, and that will not be a factor. But first of all, we have to determine if this is even a viable thing, if it's putting out enough heat to have an impact on this room. It's a very small flame, but it's a very, very hot flame. And I just don't know if that will put out enough BTUs to make an impact. So we'll see. So in a second, I'm going to light that torch. All right. So I'm going to light this torch. And I'm just going to use my butane torch to do that. I like it better than using a lighter. It's more reliable. So right here is the valve on the torch. Open that up. And I think I have it too close right now. Huh. There we go. Now maybe you can see that blue flame. I will bring you closer. All right, so there is the flame directed at the cube, and you can hear the torch over here, or the gas making mechanism, the electrolysis mechanism. First of all, you can hear the fan, cooling fan. You can see the meter saying it's about 13 amps. You can hear the bubbler bubbling as the gas is made and exuded out the tip of the torch. So you can see on that edge it is glowing red. So there you go. I mean, that's pretty much it. Just let it go. And over here, the fluid level is right about there. Excuse me, you need to be a little further. There you go. The fluid level's right there. And feeding water line. Normal water line. Oh, that's interesting. Anyway, it's making gas. I may have to add water to it. I've only run it for about maybe 15 minutes at a time. And it really doesn't have that great of an impact on the fluid level. So I have a feeling that that will make hydrogen and oxygen for hours. And of course, the cost of this is the 13 amps of electricity per, however you calculate that. There is a smell right now. It's not exactly pleasant. But I know, because it's hydrogen and oxygen, it's the only byproducts are water, and also maybe the heating of the whatever's on that crucible, which I hadn't considered because it wasn't a clean crucible. Hopefully that's not a pollutant, something that's hazardous to breathe. I probably should come up with something else to suspend that block that I know is clean. Anyway, here we'll take a second to, I'll put this back in the tripod. And I'll take a second to check temperatures again. All right, so the thing about it is this infrared thermometer has a limit on how high it can read. And I don't know why that's fuzzy. It's not focusing very well. Let me shut it off and start it again.